Hey, what's up, everybody? Welcome back to another live stream from Scalar Learning. And today we are continuing with these SAT problems, right, from Khan Academy. So let me just make sure we're good to go here. So last week we did a pretty crazy stretch, right? We did 5 live streams in a row. And they were all geared towards doing a full length, basically calculator, non-calculator SAT, which was pretty intense. So now we're going back to the regular schedule. We're just doing one section, 5 problems, knocking them out. I scheduled the live stream ahead of time, so hopefully you guys can come on and there's some people watching and you guys can ask questions if you need be, and we'll jump back and forth. All right, let's do it. So question number 1, we got 2 over 1 plus I. Which of the following is equivalent? Usually in a question like this, all we got to do is get that I out of the denominator. How do we do it? We multiply by the complex conjugate. This essentially turns the bottom into a real number. The complex conjugate is the same as this quantity, but minus I. So we do the same thing up here. Because we can't just multiply by 1 minus I. We have to make it a fraction. Same over the same. It's fine. Now these guys multiply and become 1 minus I plus I minus I squared. Okay. The reason why this is good is, hey, these guys cancel out, and I squared is negative 1. So negative 1 is like this, which is just a plus. So guess what? The denominator becomes 2. Now what about the top? This distributes, and we get 2 minus 2i, right? But now we can divide everything by 2 on the bottom. We get 1 minus I. And there's our answer. Next. We've got 3i to the 10th plus I to the 11th. Okay, how the heck do we figure this out? Well, there's a cool little pattern that we'll notice with I. I, of course, is the square root of 1. I squared equals negative 1. I cubed equals negative 1, which is I squared, times I, which is negative I. And then I to the 4th is I squared times I squared, basically, which is negative 1 times negative 1, which is positive 1. Okay, and this is the pattern. So we can kind of go through and say this pattern repeats. I to the 5th then becomes I to the 4th, which is 1 times I, which is back to I to the 6th. Here, let me move this over. And so on, I to the 7th. So we can kind of see where everything falls, but we want I to the 10th, right? So then we've got, move it over a little bit more, I to the 9th and I to the 10th, I to the 11th. So these are the ones we want, and that's in this column. So, So we've got I squared kind of lines up with I to the 10th. And I squared is negative 1. I to the 11th is I cubed, which is negative I. Okay. So then this becomes 3 times, well, I to the 10th is negative 1. Plus I to the 11th is negative I. So this becomes negative 3 minus I. We have P of n equals n squared minus 5n minus 7. What is the value of P of negative 3? So negative 3i. So we're plugging negative 3i in for n. So we replace that n and that n with negative 3i. So negative 3i squared minus 5 times negative 3i minus 7. So this becomes 9i squared minus, these two cancel out, so it's plus 15i minus 7. I squared is negative 1. Negative 1 times 9 is negative 9. Negative 9 plus negative 7 is negative 16 plus 15i. Which of the following is a solution to the equation above? Well, what do we have here? We have a quadratic, right? T squared, T, 27. First of all, I want to simplify. Actually, you know what? Can I make this easier by dividing by the square root of 3? No, it'll be a little complicated. So we're going to leave this as is. Hold on, let me just think if there's an easier way to do this. Now, I could just plug it. So clearly what they've done is plug it into, I mean, I assume is they plug this thing into the quadratic formula. I'm inclined to think A and B are wrong because there's no term up front, which it should be. So it's probably one of these two. I think it's C because the quadratic formula is supposed to be negative B plus or minus, so it should start with a negative 5. But anyways, my guess is going to be C. Let's just circle that, see if I can eliminate it that way. But then it should be over 2A. No, it's probably D. Okay, let's see. So we got negative B, which is negative 5, plus or minus. Wait, did they have plus or minus? Oh, they just have plus. Oh, so we just want a solution. So they're just probably choosing the positive. So negative 5 plus or minus negative B plus or minus B squared, which is 25, 5 squared, minus 4 times square root of 3 times square root of 27, 4AC, over 2 times A, which is 2 rad 3. Okay. So this evaluates to 3 times 27, because these are under the same square root, right? So they can actually multiply, becomes 4 rad 81. But 81, square root of 81 is 9. So this becomes 4 times 9, which is 36. So this whole piece goes to 36, so negative 5 plus or minus square root of 25 minus 36 over 2 rad 3. 25 minus 36 is negative 11. Negative 5 plus or minus square root of 11, negative 11 over 2 rad 3. And then negative 11, we can take the square root of negative 1 out as an I, so it can be negative 5 plus or minus I rad 11 over 2 root 3. Okay, so it is D, and I'm going to show you why. So I thought it would be C because of that negative 5, but look at the denominator. It's different. So if it were negative 5, and they put the I over there, which is fine. Let's put it over there. It's not in the square root. It's outside. But that's okay. So look, it's not, and it's because the denominator is wrong. But this has a denominator of 6. We don't have a denominator of 6. But if we can get this to a denominator of 6, then we can see if the top matches up, and I bet it will. So how do we do that? Well, if I multiply the bottom by square root 3, and I have to multiply the top by square root 3. Watch what happens. Square root 3 times square root 3 is 3. 3 times 2 is 6. So that's how we get a 6 on the denominator, and then we distribute the square root 3, so it becomes negative 5 rad 3 plus or minus, and then the rad 3, since it's under a radical and multiplying, it actually directly multiplies that 11 to get 33i. And that's what we have in D. It's a very, very hard problem. Okay, next. Last one, number 5. Which of the following is a solution? Okay, 29 equals 3 times x plus 7 squared plus 41. My inclination is just to solve for x, so I'm going to subtract 41 from both sides just like this. 29 minus 41 is negative 12. Then I'm going to divide both sides by 3. X plus 7 squared equals negative 4. Oops. And then we take the square root of both sides to get rid of that square, and we get x plus 7 equals, this becomes 2i. The reason why is because it's like you want to think about the square root of negative 4 as the square root of negative 1 times the square root of 4. The square root of 4 is just 2. Square root of negative 1 is I, so it's 2i. And then we're going to subtract 7. So x equals 2i minus 7. Or negative 7 plus 2i, same thing. So it's this guy. They got a lot of really interesting answers. I wonder where all these come from. Make sure I didn't do this wrong because my answers, they just seem so simple. Negative 12, negative 4, 2i minus 7 negative. Okay, I think that's right. All right, cool. Okay, so that's it. This is a short one today, and we're already done. Guys, if there's any questions, let me know, but I don't see any questions in the chat. So hopefully that answered everything you wanted to know. So make sure to check back every Wednesday for a weekly SAT live stream. But we're going to have a new schedule pretty soon. I'm hammering out the details. I'll know in a couple weeks, and it's going to be sick. We're going to have a lot of new content coming your way on the regular. Make sure to click the like button if you did like this video. And if you want to see more videos from Scalar Learning, click that subscribe button. And if you have questions on the questions that I solved, leave the question in the comment section. I try to answer, I do answer every single comment that comes in and question that comes my way. So make sure to do that. Thank you guys so much. I'll see you guys next time. Take it easy.